Hello friends, today I am going to discuss index number part 1. Let us see introduction. An index number is a measure of change in magnitude from one situation to another. The two situations may be two time periods, two regions of a country, or two groups of individuals. In economics and finance, index number is a statistical measure which reflects the relative changes in the level of certain phenomenon, say price or wages in any given period, called the current period, with respect to its value in some fixed period called the base period. The reference base is expressed as having one selected situation as 100. Another year may have an index number, say 138. This means that the magnitude in the second year is 138% of its level in the base year. The actual level is measured in neither of the years, only the change from one year to the other is given by the index. Here the index number shows the increase of 38%. There can be indices for the data of volume of trade, industrial and agricultural production, employment, bank deposits and foreign exchange reserves. Index numbers are also applied to sociologists for studying population, psychologists for studying IQs, health and educational authorities for formulating and revising their policies from time to time. For economic and business study, index numbers may be broadly classified into three categories. 1. Price index numbers, 2. Quantity index numbers and 3. Value index numbers. The price index number measures the general changes in the prices. The two specific types of price indices are wholesale price index numbers and retail price index numbers. Quantity index number studies the changes in the volume of goods produced, distributed and consumed. These indices can be computed for agricultural, industrial production, imports and exports. Value index number measures the change in the total value of production, such as indices of inventories, sales and profits. Here value equal to price multiplied by quantity. For constructing index numbers, select a basket of items that need to be focused for the study. All the items may not have same unit of measurement. For example, if we are constructing index numbers for the set of household commodities such as cereals, milk, cloth, petrol and electronic items, all the commodities do not have the same unit of measurement. Cereals may be quoted in rupees per kilogram or quintal. Liquids like milk and petrol may be quoted in rupees per liter. Cloth may be quoted in rupees per meter and so on. Some are costly goods and others are cheap. Some are essential goods while others are luxury items. So, to balance their importance of use and to construct an index number, which is unitless, different authors have given different procedures of constructing index numbers. They have adopted different ways of assigning weights to the commodities. Let us see different types of index numbers. Consider n commodities. Let the given data be the prices and quantities for these n commodities. The data relate to specified groups of buyers or sellers in defined markets or geographical areas and for particular time periods. The prices and quantities of the n commodities in year 0, that is base year, be denoted by Pi0 and Qi0 for I equal to 1, 2 up to n. So, we write summation I running from 1 to n Pi0 into Qi0 equal to only summation P0 Q0 and similarly other expressions. There are some index numbers constructed by using different systems of weighting. Number 1. Last year's price index number. The notation for last year's price index number is P01LA, which is given by summation P1Q0 divided by summation P0Q0 multiplied by 100, where P01 indicate the price index for the current year with respect to the base year. P0 is the price of commodity in the base year, P1 is the price of commodity in the current year, and Q0 is the quantity of the commodity in the base year. In this index number, the base year quantities are taken as weights. This method of computing price index is called base year method. Second, Paste price index number. The notation for Paste price index number is P01PA, which is given by summation P1Q1 divided by summation P0Q1 multiplied by 100, where Q1 is the quantity of commodity in the current year. Here, the current year quantities are taken as weights. Third, last year's and past year quantity index numbers. The quantity index number given by last pay is denoted by Q01LA given by summation Q1P0 upon summation Q0P0 multiplied by 100, and quantity index number given by past year is denoted by Q01PA, which is equal to summation Q1P1 upon summation Q0P1 multiplied by 100. By convention, year 0 is the earlier and year 1 is the later year. The comparison from year 0 to year 1 is called forward. Equally, the backward comparison is from year 1 to year 0. So, P01 and Q01 are forward and P10 and Q10 are backward index numbers of price and quantity. That is, P10LA equal to summation P0Q1 upon summation P1Q1 multiplied by 100, and Q10LA equal to summation Q0P1 divided by summation Q1P1 multiplied by 100, and P10PA equal to sigma P0Q0 upon summation P1Q0 multiplied by 100, and Q10PA equal to summation Q0P0 divided by summation Q1P0 multiplied by 100. Let us see the value index. This measures the changes in the value of a group of commodities in the current period with respect to the base period. It is given by V01 equal to summation P1Q1 divided by summation P0Q0 multiplied by 100. Example 1. From the given data, construct the last year's, past year, price and quantity index numbers. Also compute value index number. So, this is the data regarding the base year, current year, price and expenditure. Here we have given 4 commodities which is given in column number 1, A, B, C, D. Corresponding units for A is liter, for commodity B is meter, for commodity C is kilogram, and for commodity D is square feet. Its price per unit are given in the third column, for A 2, for B 4, for C 1, for D 5, and corresponding expenditures in rupees given in 40, 16, 10, 25 in column number 4. Similarly, the price and expenditure for current year are given in column number 5 and 6. Let us see the solution for the problem. Here we define expenditure equal to price into quantity, and therefore, the quantity equal to expenditure divided by price. Using this formula, from the given expenditure and price, we can calculate the quantity for base year and current year. It is demonstrated in this slide. See, the first column is commodities A, B, C, D. Second column is the price for base year. Third column is the quantity for the base year. Fourth column is the price for current year. Fifth column is the quantity for the current year, and then next columns indicate P0 into Q0, P1 into Q1, P0 into Q1 and P1 Q0. From the earlier table, we can calculate summation P0 Q0 equal to 91, summation P1 Q1 equal to 199, summation P0 Q1 equal to 92 and summation P1 Q0 equal to 202. Hence, Laplace price index number is given by the formula P01 LA equal to summation P1 Q0 divided by summation P0 Q0 multiplied by 100. Substituting the value of summation P1 Q0, which is 202, and summation P0 Q0 is 91 multiplied by 100, we get the answer 221.98. Similarly, Laplace quantity index number given by Q01 LA equal to summation Q1 P0 upon summation Q0 P0 multiplied by 100. Substituting the values of both the summations, we get 92 upon 91 multiplied by 100 equal to 101.1. Passe price index number given by P01 PA equal to summation P1 Q1 upon summation P0 Q1 multiplied by 100. Again substituting the values of summation P1 Q1 and summation P0 Q1, we get 199 divided by 92 multiplied by 100 equal to 216.3. Passe quantity index number given by Q01 PA equal to summation Q1 P1 divided by summation Q0 P1 multiplied by 100. Substitute the values of summation Q1 P1 and summation Q0 P1 from the earlier table, we get 199 divided by 202 multiplied by 100 equal to 98.5. And let us finally calculate value index number, which is V01 equal to summation P1 Q1 divided by summation P0 Q0 multiplied by 100, which comes out 199 divided by 91 multiplied by 100 equal to 218.68. Let us see relation between Laplace and Passe's index numbers. In this section, we consider some types of relationship between both the index numbers. Number 1, suppose V01 equal to summation P1 Q1 divided by summation P0 Q0 is the change in the actual value from year 0 to year 1. Then P01 PA equal to V01 upon Q01 LA and Q01 PA equal to V01 divided by P01 LA, or the same expressions we can write P01 into PA multiplied by Q01 into LA equal to V01 and P01 LA multiplied by Q01 PA equal to also V01. Second, the Laplace and Passe index forms are related so that the reciprocal of the forward Laplace index is the backward Passe index and the reciprocal of the forward Passe index is the backward Laplace index. That means P10 PA equal to 1 upon P01 LA and P10 LA equal to 1 upon P01 PA, or P10 into PA multiplied by P01 into LA equal to 1 and P10 LA into P01 PA equal to 1. Third, from the first property we have P01 PA into Q01 LA equal to P01 LA into Q01 PA equal to V01. This implies that P01 PA upon P01 LA is same as the ratio Q01 PA upon Q01 LA. It follows that the ratio of the Passe to the Laplace form is same for price and for quantity index numbers. Using this property, it has been statistically proved that the Passe price index is greater than the Laplace if price and quantities tend to move in the same direction between years 0 and 1. The Laplace index is greater if price and quantities tend to go in opposite directions. Fourth, Laplace price index is based on the assumption that the quantities consumed in the base year and current year are same. This assumption is not true in general. If the consumption of some of the commodities decreases in the current year due to rise in their prices or due to changes in the habits tastes and customs of the people. Then Laspers index gives relatively more weightage to such commodities as it does not take into account falls in demand or changes in output. The numerator in the formula is relatively larger. Thus, Laspers index number overestimates the true value and is expected to have an upward bias. Passe, on the other hand, tends to understate the rise in prices because it uses current weights. In practice, neither all prices nor all quantities move in the same ratio, and the relationship between the two systems depends on the correlation between the price and quantity movements, which is normally negative. That is, as one increases, the other decreases. Therefore, those goods which have rise in price more than others at a time when prices in general are rising, or the reverse, will tend to have current quantities relatively smaller than the corresponding base quantities, and they will thus have less weight in Passe index. The Passe index number underestimates the true value and is expected to have a downward bias. The Laspers index is probably more convenient to use since it uses fixed weights, but it is found that with the passage of time these weights become out of date. The Passe index uses the current weights, but it is sometimes difficult to obtain up-to-date information, and in that case Laspers formula is more advantageous. Let us see other forms of index numbers. In search of perfect index number, some compromises have been made and the other formulae have been discovered. Number 1. Marshal Advert price index number. Here the weights attached to the commodities are taken as the arithmetic mean of the quantities in the base year and current year. That is, weight W equal to Q0 plus Q1 divided by 2, and the Marshal Advert index number is given by P01ME equal to summation P1 multiplied by into bracket Q0 plus Q1 divided by 2 divided by summation P0 into bracket Q0 plus Q1 divided by 2 whole multiplied by 100, which we can simplify as summation P1 Q0 plus summation P1 Q1 whole divided by summation P0 Q0 plus summation P0 Q1 multiplied by 100. Second, Dorbis-Bowley price index number. It is the arithmetic mean of Laspers and Passe price index numbers. It is given by P01 dB equal to 1/2 of P01 LA plus P01 PA. That means 1/2 into summation P1 Q0 upon summation P0 Q0 plus summation P1 Q1 upon summation P0 Q1 whole multiplied by 100. And third, Fisher price index number. It is the geometric mean of the Laspers and Passe price index numbers. It is given by P01F equal to square root of P01 LA into P01 PA, that is square root of summation P1 Q0 divided by summation P0 Q0 multiplied by summation P1 Q1 divided by summation P0 Q1 whole multiplied by 100. In general, the true value of the price index lies somewhere between the Laspers price index and Passe price index number. Both Marshal Advert and Fisher index numbers lies between Laspers and Passe indices. They have no bias in any known direction and provide a better estimate of the true price index. Let us see example 2. Using the data of example 1, we compute A. Marshal Advert price index number, B. Dorbis-Bowley price index number, C. Fisher price index number. Let us see the solution for the problem. Let us repeat the data of example 1 in this slide where first column indicate the commodities A, B, C, D, second column indicate the price for base year, third column quantity for the base year, fourth column price of the current year, next column is the quantity of the current year, and then after the columns indicate the values of P0 Q0, P1 Q1, P0 Q1 and P1 Q0. From this table, we can find summation P0 Q0 equal to 91, summation P1 Q1 equal to 199, summation P0 Q1 equal to 92 and summation P1 Q0 equal to 202. Let us calculate first Marshal Advert price index number. By formula of Marshal Advert price index number, P01ME is given by summation P1 Q0 plus summation P1 Q1 divided by summation P0 Q0 plus summation P0 Q1 multiplied by 100. Substituting the values of all these four summations, we get 202 plus 199 divided by 91 plus 92 whole multiplied by 100, which comes out 219.13. B. Dorbish-Bowley price index number given by P01 dB equal to 1 upon 2 into bracket P01 LA plus P01 PA, which is equal to 1 upon 2 into bracket 221.98 plus 216.3, which comes out 219.14. C. Fisher price index number. By formula P01F equal to square root of P01 LA into P01 PA. Substituting the answer of P01 LA and P01 PA, we get square root of 221.98 multiplied by 216.3, which comes out at 219.12. Let us see fixed and change base index numbers. The various formulae discussed for the construction of index numbers are based on the fixed base method. They reflect the relative changes in the level of phenomenon in any period called the current period with respect to its value in some particular fixed year called the base year. Fixed base indices, though simple to construct, have some limitations. The drawback of the fixed base method is that it requires the same set of commodities to be used in both the periods. The relative importance of the various commodities may change due to the changes in the consumption patterns of the society, and as such weights need to be revised. In view of these limitations, it was felt that the data for the two periods being compared should be as homogeneous as possible, and this is the best obtained by taking two adjacent periods. This requirement has given rise to change base method, where the relative changes in the level of phenomenon for any period are compared with that of the immediately preceding period, and the process is continued till the comparison is made with the required base period. 1. Construction of change base index number. The change base index number for any year is calculated using the formula link relative of current year multiplied by change base index of the preceding year divided by 100, where link relative of any year equal to price of that year as a percentage of its price in the preceding year. That means link relative for the ith year equal to Pi divided by Pi minus 1 multiplied by 100, where I takes value 1, 2 up to n. Let us see example 3. From the following prices of the three groups of commodities for the years 2001 to 2005, find the change base index numbers chained to 2001. In column 1, we have given groups denoted by A, B, C. Second column indicate the values for 2001, third column for 2002, next column for 2003, thereafter 2004 and 2005. Let us see the solution. In this table, the first part indicate how to calculate link relatives for the different years. The third column, fourth column, fifth column and sixth column indicate the method of calculation of link relative. Let us demonstrate one value. For the group A for 2002, the link relative is calculated by 12 divided by 8 multiplied by 100, which comes out 150. Similarly, for group B, it is 40 divided by 32 multiplied by 100, which comes out 125. And for group C, it is 20 divided by 16 into 100, which comes out 125. The similar way for other years, the link relatives for the three groups ABC are calculated. After calculating the link relatives, the total is made, it denoted in the third row, where total for the 2001 is 300, for 2002 is 400, for 2003 is 413.33, for 2004 the total is 375, and for 2005 the total is 360. Based on this total, we find the average. This average is nothing but the total divided by 3. So, 300 divided by 3 we get 100. Similarly, 400 divided by 3 we get 133.33, and similarly for the next 3 columns the average values are 137.78, 125 and 120. And then applying the formula of chain based index number, the index number are calculated. For first year remains as it is, the value of link relative, but from the second year the chain index is given by 100 multiplied by 133.33 divided by 100, which comes out 133.33. Similarly, for the year 2003, the chain index is given by the link relative of the 2003 multiplied by the chain index of the earlier 2002 divided by 100. That means 137.78 multiplied by 133.33 divided by 100, which comes out 183.70. In similar way, the chain index for the year 2004 comes out 229.63, and for 2005 it comes out 275.56. Second, construction of fixed base index number from chain base index number. Fixed base index denoted by FBI can be obtained from the chain base index denoted by CBI using the following formula. Current year FBI equal to current year CBI multiplied by previous year FBI divided by 100. The FBI for the first period is same as the CBI for the first period. Let us demonstrate the example to apply the above formula. Example: from the chain base index numbers given below, prepare fixed base index numbers. We have given year from 1990 to 1994 and corresponding index 90, 120, 130, 105 and 150. Using the above formula, we obtain the fixed base index numbers as given in the following table. First column indicate the year, second column are the given values of chain base index number, and in third column we wish to calculate fixed base index numbers. For the first year, the fixed base index number remains same as the chain base index number, so it is 90. For next year 1988, chain index number is 120, corresponding fixed base index number of the earlier, that means 90, multiplied by chain index number of the current year, which is 120, divided by 100, which comes out 108. Similarly, for the year 1989, the fixed base index number is calculated as 108 into 130 divided by 100, which comes out 140.40. Similarly, for the year 1990, the fixed base index number is calculated as 140.40 multiplied by 105 divided by 100. So, we get 147.42, and for the last year 1991, the fixed base index number is 147.42 multiplied by 150 divided by 100, which comes out 221.13.
Let us summarize the chapter. An index number is a measure of change in magnitude from one situation to another. The two situations may be two time periods, two regions of a country, or two group of individuals. For economic and business study, index numbers may be broadly classified into three categories. Number 1, price index number. Number 2, quantity index numbers. Number 3, value index numbers. Different authors have given different formulae of constructing index number by adopting different procedures of assigning weights to the commodities. These index numbers are: number 1, last year's index number; number 2, past year's index number; number 3, Marshal Advert index number; number 4, Dorbish-Bowley index number; number 5, Fisher's index number. These fixed base indices have some limitations. The consumption pattern of the people change, there may be new innovation, and the relative importance of the commodities may also change. In view of this limitation, the chain based index number has been constructed, which measures the change in the level of a phenomenon for any period with that of the immediately preceding period, and the process is continued till the comparison is made with the required base period. Thank you.